InfinityGreedy. In our previous video, we have seen how quickly we can sort an array using insertion sort. But in this video, we are going to see how actually the insertion sort works, what are its key points and its definition and how it works, right? So to get started with, I just wanted to introduce one point about insertion sort is that it is based on decrease and conquer methodology. When I say decrease and conquer methodology, many of you got what I mean. But those who do not know about decrease and conquer, we have already having many videos on this approach. Because BFS, DFS, fake coin problem, Joseph's problem, right? All these problems are based on decrease and conquer. Alternatively, what you might have heard is divide and conquer. So divide and conquer and decrease and conquer are two different things, right? Divide and conquer, I'll just give a basic of this, okay? So those people who are very new about these, they can also understand. Divide and conquer is basically, for example, you have an array, I'm just giving an hypothetical situation, and you divide it. So you need to focus on this part also, and you need to focus on this part also. That is what you divide and then you conquer. Rather than taking a whole array into consideration, you work in small chunks. So you will work on this part also, and you're gonna work in this part also. But decrease and conquer, what it says, if you have an array and you have, let's say, I'm just giving, if you divide it by 2, you don't have to work on both the parts, you just need to work on the one part. So basically what we do, we exploit the relation between the solution to a given instance of the problem of a solution to a smaller instance of the same problem. For example, if I have to sort an array, right? So I will divide into two parts and I'll consider one part as sorted and other as unsorted. Are you getting it? If not, I'll just make some other more points on decrease and conquer. If you are not understanding, let's see if we can. So right, so here you can write it is like divide and conquer, but rather than dividing rather than dividing the problem into two parts or halves, we decrease the size of the problem instance. Okay, we decrease the size of the problem instance, right? Or you can write same, if you are not getting this also, you can write that in decrease and conquer, we exploit the relationship between a solution to a given instance of the problem and a solution to a smaller instance of same problem. Okay, so we are going to see, don't worry, right? We are going to see examples, right? And those who know that decrease and conquer has, three variants. One is decrease by one. So insertion sort algorithm is part of decrease by one, right? We'll see how this insertion sort algorithm is there. You will figure it out, okay, why we are calling it as decrease by one. Then you have decrease by, constant factor like n by 2 and how it is, and you have variable size. For variable size, for example, you need to find this median in partitions, right? By constant, like your DFS, no, DFS is by again by 1. Your Joseph's problem comes under this decrease by constant, right? So decrease and conquer. So first important point we need to conclude here is that insertion sort is example of decrease and conquer. Means we are going to decrease the problem and then we're going to conquer, then going to fight with the problem, right? All right. Now what happens actually in insertion sort? Now you can write that in insertion sort, it is a simple, you can write it is a simple algorithm that works by iteratively iteratively inserting each element. Remember this, each element of an unsorted unsorted list into the correct position in a sorted portion into a sorted portion portion of the list. Now you might have got the idea what we are doing. It is a simple that works iteratively inserting each element, that is why decrease by 1 of an unsorted list into the correct position in the sorted. So what we are going to do, whatever the array we are going to have, we are going to divide into two parts. One we are going to say sorted and other we are going to say unsorted. Okay, now what we are going to do, element of an unsorted array into correct position. So from here I am going to put my element into the sorted array. So at the end I will have all sorted and none unsorted. So if you have seen my previous video where I have quickly shown you how to do any question of insertion sort, we used a slider, right? So that slider act as a intermediate between sorted and unsorted. So any number before this or left to this was considered as sorted, and all the elements which are right to are considered as unsorted. Does it make sense? Or if you want to take a feel, right, how insertion sort actually work. So consider, let's say you have a stack of cash. Okay. So let's say, okay, many a times in India, right, what we do is we basically, let's say I have 100 rupees, 200 rupees note kept on each other, right? It's like we are creating a stack, and then I have 50 rupees note, three notes, and I have, let's say, 10 rupees note, five. Okay, so they are kept on each other. Okay, so they are kept on each other. 100, then you have 100, then you have 50, 50, 50, 50, and then you have 10, 10, 10, 10 like this, right? Now, means you have already sorted, you have uh, sorted them or you have kept them in a sequence, right? 10, then 15, then 100, according to their dimensions. Now, if 20 rupees note comes, you know where to insert it. You know this note will come here. It will come here in between, right? The 20 notes will come here in between. So that is why it is called as insertion sort. The same uh, method we are going to apply when we are going to sort the array, right? So if you want to write, right, so what we do to sort an array, let's say this is my n minus 1 array, we assume that a to 0 n minus 2 is already sorted, and just we need to take decision where to insert this a n minus 1th element, right, in the entire list. That is why it is called as insertion sort. If you have any doubts and confusion, please have a patience and check our next video where we have taken an example and we have seen how actually this insertion sort talks about, and whatever we have talked here in this video will make sense there. So if you like this video, please do like, share and subscribe. Thank you.